All right. All right, here we go. 3, 4. Suppose you are laying tiles. You ever tile the floor? You ever looked at tiles on a floor? All right. You have several different rectangles together to form a large rectangle. BC is parallel to DF. So if I look at BC right here, is parallel to DF. DF is parallel to GH. What is the relationship between BC and GH? How do you know that? How do you know that? What is the rule that we learned that says if BC is parallel to DF and DF is parallel to GH, then BC is parallel to GH? What is it? What is it? Oh, what is it though? What's it called?
No, it is
What is it? What is this called? Katie, what's this called? If BC is parallel to EF or DF and DF is parallel to GH, then BC is parallel to GH. What's that called? What? Siligus? Law of Siligus? Law of Siligus? All right. So we know that since this one's parallel to this one and this one's parallel to this one, then these two right here, not that one, these two right here are parallel. Do you like that? Draw a line in the middle between two lines. All right. If BK is parallel to EL, and GH right here, GH is perpendicular to BK. What is the relationship between GH and EL? GH and EL. We don't really have a law. What's the relationship? If we know this is perpendicular, what's the relationship with this one and be in there? If it's perpendicular to one parallel line, if two lines are parallel and a line is perpendicular to one, it's perpendicular to the other one, isn't it? No. Let's take a look at this. Let's see. A student says that according to Theorem 3.9, AB is parallel to BC. What's Theorem 3.9? I don't have that up here, do I? I don't have that up here. A student says according to 3.9, AB is parallel to BC. AB is parallel to BC. It's on a plane. It's on a plane. This is a plane here, and it sits up on top. So this is like taking a notebook like this, and I'm saying that this line here is parallel to this one because it's on the same plane. They're parallel on the plane. They're parallel on the plane. Because they are perpendicular to BF? BF? Are these both perpendicular to BF? Are they? Then if they're both per what we set up here, then AB is parallel to BC. It's parallel on a plane. It's different than look at it three-dimensionally. Look at it three-dimensionally. If I take a plane, if I say on a plane, all right, and I've got this plane is all, one sheet right here, and I say this edge right here on the plane is parallel to this one. It's on the plane. It's on the same plane. All right? It's not two-dimensional. It's three-dimensional. They're on the same plane. And we drop a line straight down from it. They're both perpendicular, right? So that means these are on a plane. They're parallel. All right. That's all good stuff. Let's take a look at number 5. Let's take a look at number 5. A puppeteer cuts the pieces shown at the right of the frame, these pieces right here, at a puppet theater. Will the sides of the pieces on the left and right be parallel? Are these parallel? Are these parallel? Yes. Why? Parallel. Why wouldn't they be parallel? What do the two angles add up to? 40 plus 60? That's 100. And 100. If you had two angles at 100 degrees, would they be parallel? No, because they'll touch sooner or later. Yeah, they're not parallel. All right. Well, yeah, eventually they would touch. They're not parallel to each other. You want to know something? I have never heard so much whining in my life. Looks like I'm going to have to give extra work today. All right. Let's look over to these properties, or these theorems. These are the ones that we were talking about before. Theorem 3.8. Suggest you learn these. Suggest you learn these. Transitive property of parallel lines. If two parallel lines are parallel to the same line, then they are parallel to each other. That's what we figured out in that first one, right? We had if A is parallel to B and B is parallel to C, then A is parallel to C. All right? This is theorem. I want you guys to know this. Theorem 3.8. I want you to know it. This is the parallel line theorem. Theorem 3.9. What does 3.9 say? If two lines are perpendicular to the same line, then those two lines are parallel to each other. So in this case here, A is perpendicular to D, and B is perpendicular to D, right? Then A and B must be parallel. Or if I go the other way around and I say if two lines are parallel, and I run a perpendicular line through them, right? Or I run a line through them that one's perpendicular to one of them, then it has to be perpendicular to the other one. That's how that one thing works. I didn't realize it. And then theorem 310. If a line is perpendicular to one of the two parallel lines, then it is perpendicular to the other line. All right, that was just the reverse of what I said here. These are actually just reverses of each other. All right, this one says here, if two lines are perpendicular to the same line, then those lines are parallel. This says if a line is perpendicular to one of the parallel lines, then it's perpendicular to all the parallel lines. All right, in this case here, we have three parallel lines, A, B, and C. D is perpendicular to each one of these. All right? Theorems that you have to know. Let's do, look at this good proof. Yes. 1, 2, your grade. Let's take a look at 3.4.2. A carpenter is building a cabinet. A decorative door will be set into an outer frame. If the lines of the door are perpendicular to the top of the frame, what must be true about the lines? They're all parallel. No, if they're perpendicular, if all lines are perpendicular to this top line, then all these lines must be parallel. The outer frame is made from 4 separate pieces of molding. Each piece has the angled corners as shown. When the pieces fit together, will each set of sides be parallel? Well, what do we have to do to make sure that this is parallel? What does this have to be? A 90-degree angle, right? So does 35 plus 55 add up to 90? Yes. So we know that this is true, this is true, this is true, and this is true. And if that's the case, then these sides are parallel to each other. All right? According to 3.9, lines that are perpendicular to the same line are parallel to each other. So since each line is perpendicular to the top of the outer frame, all lines are parallel. I want you to do number 3. Don't worry about number 4. 1, 2, and 3. 3 problems.
I can't count that high.
That I believe.